So I wanted to go through and actually talk about the balance point diagram that we're going to be looking at. Notice that the numbers that go between 0 and 70, that actually is the temperature outside. And then you have 0 to 100,000 BTUs up there. Now, when we talk about our houses, what we'll usually do is say at an outdoor temperature of 0 degrees, that it will require 55,000 BTUs of heat to heat that particular house that we're in. And that's just a fictitious number I'm coming up with because we haven't done a heat load on the house at all. But for the example of how to draw your lines on this balance point diagram, we're just going to say it's 55,000 at 0 degrees. And then we say at 65 degrees, which is this mark right here, that we need 0 BTUs of heat to actually heat that house. So what we'll do is we'll draw a line between those 2 points of the diagram, and that will be the heat loss of the house as the temperature outside actually goes up or down. Now the next lines that we want to put in there happen to be what the heat pump is going to be producing for us. Remember, AHRI comes out with data ratings, data ratings or heat output of that air-to-air heat pump for every heat pump that's ever made. So what we're going to say is at 47 degrees, so 40, 42, 44, 46, 47, at 47 degrees, that this particular heat pump is capable of producing 40,000 BTUs of heat. So at 40,000 BTUs of heat, we'll draw a line over until we hit 47 degrees, and that happens to be right there. And then AHRI comes out and says at 17 degrees. Why do they do that? I don't know why they use odd numbers, but we're going to check it at 17 degrees that it's capable of producing 10,000 BTUs. And remember, once again, these are fictitious numbers. Now we'll draw a line between those 2 points. And where the 2 marks meet, the house and the heat pump, that is referred to as the balance point. Now we can say that the balance point is at roughly 33 degrees, and the BTU output of that heat pump over there is 26,000 BTUs. So that's what we'll say the balance point is on this diagram. Now, if we were to add an electric heat strip to this diagram itself, we'd basically add about 17,000 BTUs of heat to it, and we would end up somewhere around 43,000 BTUs. So we'd come up to the 43,000 BTU mark, and I would draw a line straight across for that. Okay, let me draw a line up. And then I want to use the same angle as the heat pump. I want to try to get it as best I can, the same angle as the heat pump, where those 2 marks meet. And I'm going to consider this to be my new balance point on this diagram. And what that means is if I add the heat pump and 1 strip heater, that the heat loss of the house and 1 strip heater are going to end up being somewhere around 24 degrees with a BTU output of 33,000 BTUs, heat loss of the house. So hope this was better. Hope this better explained what a balance point is and how to draw out the lines. And you guys have a good day.